Now for this problem, we do not have the form that I initially presented. And the problem with this is the absolute value of 2u plus 5. The coefficient on u is not 1. It has to be 1. But we can factor any positive value out of an expression contained in absolute values. So I'll factor a 2 out of that. And so we have u plus 5 halves. The absolute value of that is less than or equal to 5. Now, multiply through by 2 and verify that you'll wind up at 2u plus 5. 2 times u is 2u. 2 times 5 halves. The 2's are going to divide out and you'll be left with a 5. Okay, next step. We want to get rid of this 2, so we'll divide both sides by 2, and we have 5 halves. Now, we're ready to draw our number line. The center is at, what's the opposite of plus 5 halves? It's negative 5 halves. Now we're going to go 5 halves in either direction. And since there's an equal sign associated with the inequality, we'll use solid circles. Now, adding 5 halves to negative 5 halves, we land at 0. Subtracting 5 halves from negative 5 halves, will land at negative 5. Now, if a point in an interval satisfies an inequality, then every point in that interval will satisfy that inequality. So, let's check a point in this interval. We have, by the way, 1, 2, 3 intervals. Let's pick a point in this interval. How about negative 100? Replacing u with negative 100 and adding 5 halves to that, will you agree? Let's see, that's going to be negative 97.5. And the absolute value of that is not less than 5 halves. So this negative 100, that point did not satisfy the inequality, so therefore no point in this interval will. On the other hand, if we replace u with negative 5 halves, we get 0, and 0 is less than 5 halves. Hey, this point satisfied the inequality, therefore every point in this interval satisfies it. Now let's try a point in this interval, such as 100, and adding 100 to 5 halves and taking its absolute value, we fail to be less than 5 halves. So since 100 failed to satisfy the inequality, every point in this interval will fail. Now we're ready to state our solution, and in set builder notation, that'll be the set u such that negative 5 is less than or equal to u, which is less than or equal to 0. In interval notation, this was set builder notation. Interval notation, we're at negative 5 to 0, bracket, bracket. And we'll move on. For our final problem, the first step is to isolate the absolute value. And so we'll add 4 to both sides, and we wind up with the absolute value of the quantity 1 minus 2x being greater than, and 4 minus 1 is 3. The next issue we have this 2 here. That's not the form we were shooting for. So we'll factor a 2 out of each term, and we get 2 times 1/2 minus x. The absolute value of that is greater than 3. Next step, we'll divide by 2. So we get the absolute value of 1/2 minus x is greater than 3/2. Now, we're ready to graph. What's the opposite of, what value of x takes this to 0? 1/2 does. Replacing x with 1/2, we'll get 0. So 1/2. Now the distance is 3/2. Distance of 3/2. Open circle, no equal sign associated with the inequality. Now 1/2 plus 3/2 is 2. 1/2 minus 3/2 is -1. And we're ready to shade. Give myself a little more room here. Now let's pick a point in this interval and see if the inequality is satisfied. I'll pick a point like -100. Replacing x with -100, a negative times a negative is positive, and the absolute value of 100 plus 1/2 is greater than 3/2. So since one point satisfied the inequality in this interval, every point in that interval will satisfy. We've got this interval, and 1/2 is in it. We replace x with 1/2, we get 0, and 0 is not greater than 3/2. So no point in this interval will satisfy the inequality. On the other hand, if we allow x to be something like 100, we'll have -100 plus 1/2, and the absolute value of that, which would be 99 and 1/2, is greater than 3/2. So one point in this interval satisfied the inequality. Therefore, every point in the interval satisfies the inequality. In set builder notation, the solution is x such that x is less than -1 or x is greater than 2. In interval notation, we have -∞ to -1 parenthesis union with 2 to infinity, and we are done.